Okay. This was very much last minute. I procrastinated until last night, and I was up till 5 in the morning. But I'm good. So this all came of working for a cheap company and, having lots of virtual machines to do something with. So rather than rather than direct attached storage, which isn't very flexible, we thought, well, why not get a SAN? And it turns out they're all like $30,000 or $40,000 or something. No one told me this. So I started looking at OpenFiler, and it turned. Hello, hello. Okay. So I started looking at OpenFiler, and it turns out if you want high availability, you've pretty much got to configure it yourself anyway. So the pretty web interface is, well, kind of useless. So I took CentOS and DRBD and an iSCSI target and put it together, and that's oversimplifying, and pretty much got a comparable system. So basically, the one caveat is that the failover is a little slow with this system. It's not like a commercial SAN where it's instant. It's not on the same device. So you're looking at about 15 seconds. So if it's something really time sensitive, you're going to want multipath. So those are the three components I mentioned. And I think what I'm going to do is, let's see here. I'm just going to bring up this machine and start going through the config. Let's see here. I can get this over there. Okay, that's no visible. Okay. Now, this is higher resolution than I'd expected. Okay. Okay. Why am I doing this? Okay, I blame NVIDIA. Okay, so while I'm rebooting, basically DRBD handles the disks. So DRBD configures two separate machines and presumably Ethernet, although there are faster connections you can use, and it synchronizes the two. The default method of accessing it is master-slave, where you have a primary disk and a secondary disk. The secondary disk cannot be accessed directly. The primary is the only one you touch. So on that machine, you have iSCSI talking to that disk between it and whatever application you have. If one of them fails, you want something like Heartbeat. And what Heartbeat does is it monitors both of the machines, and if one of them fails, it moves the IP, moves the iSCSI service, and kicks the machine that's misbehaving off. So DRBD, it maintains the data connection. Heartbeat monitors and makes sure it's doing the right thing. Okay. This really threw me off. do I have a projector? I think it might have. Okay. Try this again. So, and this setup, given that we're doing multiple disks on a tiny little laptop disk, it's not optimal in and of itself, but it'll serve its purpose. Just to be patient. I was actually worried I wouldn't be able to fill my hour. There we go. Yeah, I previously cloned two of these DRBD nodes, and I planned on breaking it down and configuring it, but I figured that would probably cause problems and take a long time, so especially on this laptop. So I'm going to go through the configs, starting with DRBD, which is actually a lot more simple than you might think. Heartbeat is not nearly as simple. It stores all of its config files in individual, you put them in XML files. It's all XML, but you piece it together in the system so you read them in one at a time, and that way you keep all of your components separate, but it's a little intimidating. And physically on this setup, the DRBD replicates its data over the second Ethernet interface, iSCSI, and all the other stuff is on the first interface. That's how you would want it in a production system too. That way the two don't run over each other. Because you can only write to the disk as fast as it can replicate to the other node. Okay. Okay, so the DRBD config is actually pretty straightforward. Global is everything that has to do with just DRBD. Common is everything you want to apply to all of the resources. A resource is a pair of disks on any machine, or 3 disks if you go with a newer version. You can actually replicate to a 3rd disk. Yeah, I can do that. Okay. Okay. So global is DRBD. Common is anything you want to apply to all resources. The protocol, that is, it defaults to A. Protocol A, what that means is that you write to the disk, it sends the data to the other machine, it writes it to the other disk, and then it sends a message back and says, okay, that worked. All before you can write again, which is why the replication link limits your speed. There's another protocol, C, that sometimes is used, and it just writes it to it, and the moment it gets out of its TCP stack, it goes again. And it doesn't care how fast it can write, it just writes and writes and writes and buffers up, which is good for backup situations, but you risk data loss. So here. This handles what it does when both nodes think they have the current data. All of this information, I mean, a lot of this is copied verbatim from drbd.org. They have incredible how-tos, even on Heartbeat. Let's see here. Here's the meat. Let's see. The meat of it is right here. You specify the name of each node, the name of the DRBD disk, which is the top level that replicates to the physical disk, and the physical disk. The physical disk doesn't have to be the same. You can replicate between RAID 1 on one machine and a single disk on another if you don't need redundancy on top of your redundancy. The IP address, for every resource, you have to use a separate port. It's kind of arbitrary. And the metadisk internal, that means that instead of storing it on a separate disk, it stores it on the disk that it's replicating. If anyone has any questions, please interrupt me, because I'm probably not going through this in a very logical fashion. But that metadata takes up a little extra space, so you can mount the raw disk itself and get the data off of it. But if you format over it, you'll probably overwrite that metadata. So that's why you only really want to work through the DRBD. Okay. Oh, okay. Okay. Okay, so these are the Heartbeat files I created. And actually, probably not even worth going into. I'm going to skip to starting this thing up. So here, let's start this thing. And to okay. So right now it's just starting up. It hasn't picked which machine is the controller, which machine is actively monitoring, and there's a small problem. But okay, so it automatically resolved where they both thought they were primary because my laptop crashed. So look at it again, and everything's going. So Heartbeat, this is Heartbeat. This is the management interface for Heartbeat. And it shows you everything it's managing, which in this case is the DRBD pair and the resource group, which contains the virtual IP that floats between the two, and the iSCSI daemon, which is IETD. Can everyone see this fairly well? Okay. DRBD itself you don't start it up on boot. You let Heartbeat do everything. Heartbeat starts everything, so the init script is useful for status, but that's about it. And right now everything's pretty much in working config. Let's see. I'm on the wrong one. Okay. So. And you can see that on each machine, it's in reverse order. So the order is reversed. You have primary and secondary and primary. It refers to itself first. Now, so to manually move a resource, if something doesn't fail, you can move any component because there are constraints. And the constraints, you put in constraints and resources, and the constraints tell the resources where they can run and what has to run first. So I wanted to move, since this is currently running on 0, if I wanted to move it to 1, I could just move any component to it. Okay, well, it's a little quicker than... So it puts them both into secondary, then it puts the next one in master, and then it starts up the components that are linked to it. Now, and this can be used with anything that uses iSCSI. The only caveat is that if you're using ESX, it's a little picky. Pretty much anything you connect it to, they work with the manufacturer and come up with a list of steps. You have to do all of these things to make it work right. They didn't create those steps for this, so it involves a lot of tweaking. But for simplicity, I'm just connecting Windows to it. Here. Actually, while this is booting, you can see that's this 199 is the floating IP I've configured. And if I go over here and I move this back, you can watch. And there it is. The floating IP floats. And that's the IP you're going to reference anytime you use anything. The IP you configure in Heartbeat. And that's in the group. And the IP address is configured up here. That's the top. So over here. Okay. Yeah, basically, when you set it up, the first step is to create the DRBD disks. So you create the initial disk, and then you create the second disk. And the order is irrelevant unless those disks have data you want to preserve. So you just create them, and then since they both think they're inconsistent, they both don't know what's going on, you connect them to each other, and then they see each other, and they say, okay, well, we're both inconsistent. And then you just pick one. And then you say, okay, well, you're primary, ignore the other guy's data, and it overwrites the second disk. And at that point, they're consistent. And from then on, you can pretty much stop DRBD and turn it off and let Heartbeat do everything. So then Heartbeat starts it up as needed and manages everything. And really, you don't have to write anything to the disk except the initial DRBD. Everything else is done through whatever application you're using. Now, this can apply to NFS, Samba, just a mount for a web server. You can put Apache in Heartbeat and have Apache move with the DRBD master, and have it just start up on the other node, mount the drive, start up on the other node, and there you have it. With NFS and Samba, well, NFS, maybe not Samba, there are some other things you have to move with it. Like NFS, it creates files under your var directory, and that has to do with every connection. That has to move with it. So you'd create another DRBD and have Heartbeat and mount it on the machine that's active. That slows things down a bit, though. But let's see here. Probably, so I already have that in there. This is the floating IP. This doesn't know where it is. It doesn't care where it is. And hopefully, okay, well, let's see here. Yep. Yeah, because it's not in use. If there were a target mounted, it would not. Yeah, I don't actually have because that was just the discovery, the portal target, not the disk itself. And it goes there and finds out what targets are available. Don't have. Okay. Oh, okay. This is actually a very simple problem. Yeah, I think it's trying to get an IP from my wireless, which isn't connected to anything. So I'm just going to set it manually. I don't know why I didn't think of this before, that DHCP wouldn't really be the same as it is at home. Okay. So I'm going to add that floating IP. And I'm not using authentication. If you do use authentication and you're using Windows, they mandate a 12-character password, but they'll let you use no password. So. Okay, I will put these all on host only. That was the problem. So, any ideas? Okay. Oh, there you go. That's probably going to have something to do with it. Okay. I see. Because it was bridged before, it disabled it for me. It's being helpful. And of course, these guys they still think they're connected because they were talking over the secondary link. So, ideally, you'd have it monitor 2 links or give it a switch to ping or something. Don't have a switch to ping at the moment. Okay. In retrospect, I should have brought a mouse. Okay, so let's see if we have something. There we go. So there we go. So log on with our non-password connected. And now, since it's already formatted, I already had it set up before, we should have E in here. We have E in here. And there's E. Actually, let me go to, let me get out of this mode so you can see the disk activity. Okay. So right now, if we look at this machine here, you can see that it's reading from the disk and sending it over the network. There's actually nothing up my sleeve. And it shows that it's running off of DRBD 0. So if I were to watch the status on this machine and just power that machine off, this ideally would see that something bad happened and take over. So if I were to go over here, I should be able to just copy from the secondary node. So, final product. Okay, so now there need to be questions because I'm terrible at this. Which you, probably about 4 or 5 hours. Just most of it was because if you go in and you install DRBD under CentOS, it's going to give you the latest, which is 8.3. 8.3 does not work with the heartbeat they give you, which probably was an oversight. So you go in to Yum, exclude DRBD 8.3, and there's another package called DRBD 8.2. It's not the version number, it's just an actual different name for the package. So you install 8.2.6, and it works fine. You just lose out on being able to replicate to a third node. But yeah, heartbeat's probably the hardest thing to get a grasp of. I'm not online, am I? Right now I have this on 2, actually it's 3, the virtual server and the 2 nodes. They're all SAS disks. SATA is, I hesitate to run anything on SATA now. I just have encountered weird problems with it under high load. Delays, the entire system locks up. I don't know if it's native command queuing or.
Are you familiar with the RE series disk from Western Digital?
Well, yes, but our company's standardized on Seagate, and it'd be a whole big, political. And then it would be on me if that first drive failed. But. Mhm. Right. I mean, you're saving enough money already. Just go SAS. I mean, you can even go nearline SAS and get like the Barracudas, 7,200 RPM, and they just retrofitted it with SAS. Then you avoid all those problems. But yeah. No, it can run it on anything. Like OpenFiler is a prepackaged solution, and it's built on RPath, and that's basically a distribution for people to build prepackaged solutions. I'm sticking with CentOS because that's just everything else runs that, and that gives us a base system to do anything else underneath. Now, our system it's all SAS, it's all 2.5-inch 10K drives, and initially I was just running software RAID 1 and software RAID 1, and the performance was terrible because I found that the 2.5-inch 10K disks are about 40% slower than the 3.5-inch 15Ks. And then on top of that, there were the entire system on top of that. It just slowed it down. I was getting like 12 megabytes a second. So that wasn't really good. So I did RAID 10, and that brought it up to pretty decent speed. I'm also running LVM on top of this. And if anyone in here has ever done an LVM snapshot and tried to write to that disk while the snapshot's enabled, you know that probably didn't work very well either. So I actually have stacked LVM on the second one. So I'm running RAID 10 and RAID 1 with LVM underneath and on top so that I can snapshot the disk DRBD writes to with it disconnected, take my backups live, and then put it back into play and it resyncs. But their documentation is phenomenal. They really took up the slack where Heartbeat left off. Heartbeat went to version 2, and then they said, okay, all of our documentation is outdated. They deleted it and didn't replace it. Yeah. So this company, they know that pretty much everyone who uses their product uses Heartbeat, so they documented Heartbeat. So drbd.org. Any more questions? Want me to break it again? Well, when it comes back up, we can watch it. Yeah, they're out of sync, so this one watches. When the next one comes up, Heartbeat starts on it, and then it looks for the master node. And then they talk to each other, and they determine who was down, who was up, and who's likely to have active data. This is all configurable through Heartbeat. But based on the parameters you configure, they come to a decision, and then the unlucky one gets overwritten. And no, that's typically you configure it so that the machine with newest data takes priority. There's really no difference between primary and secondary. The machine that is active is primary. And if you have an identical setup, you can fail over to one, bring the next one up, and not bother failing back if you don't want to deal with the risk of the switchover. It's more expensive because you need identical hardware. That's not what I'm doing, but that is ideal. Then you have two cloned machines that are exactly the same and exactly as reliable. Now, if you're doing just iSCSI and you don't need failover, OpenFiler is probably a good solution. It has a nice web interface. It's a little buggy, but the back end is solid. So Okay, it sees both of them are online. And, okay. Yeah, I have noticed weirdness in Heartbeat where if another one comes up, it tells you that things are going down and coming back up, but it's an illusion. They're really not. Oh, that is not an illusion. Let's see. What is happening here? So that's actually still up. Okay, it moved back. Okay, well, so this failed back, actually. That must have been in my config. But, a lot of it depends. The gracefulness of this process depends on what application you have on it. If you have ESX on it, it's not going to be too graceful because ESX will freak out and will not reconnect until you reboot ESX. And I'm sure that was done for a good reason. They intend on using commercial SANs with A and B connecting to that one device, not this. With Linux, what I've done is I've used multipath. And multipath allows you to set a time period in which it queues all commands. So the system writes to multipath, and multipath intercepts any kernel errors from the underlying SCSI device. So instead of the kernel saying, oh God, and remounting it read-only, it queues it all up. So for this 15 seconds, it'll queue it all up. And unless you expect data right now, you're not going to notice a difference. Yeah, pretty much. And this is a lot slower than real life. 15 seconds is probably higher than you're going to see on good hardware. And I think that's about it for me, actually.